The last tutorial was a tutorial testing differences between two groups. So essentially this is what we were trying to do. We were trying to figure out if this group and this group are different, and we were trying to figure out how different do they have to be in order to be different. And we figured out that there were two measurements that we needed to have. One was the distance between the two groups, and then we had to compare that distance between the two groups with individual differences within the groups. And that is called a t-test. And the purpose of a t-test then is to determine whether or not there are differences among two groups. So that brings us to a situation where perhaps we would like to know the difference between 3 groups or 4 groups. And here's the challenge that presents, and that is we have Group A, Group B, Group C, and Group D. B, C, D. So we want to know if there's a difference between Group A and B, A and C, A and D, and we want to know if there's a difference between Group B and C and B and D, and we want to know if there's a difference between Group C and D. So that brings us to 1, 2, 3, 4, 5, 6 separate tests that we would have to do. So what do we need to do? We need to do 6 separate t-tests in order to determine if there's a difference among 4 groups. Well, that presents us with the alternative, which is maybe we can make one statement that there are differences between those groups without being specific about where those differences lie. How might we do that? Well, let's assume, for example, that we have this category of employees. And one group of employees came from Ivy League schools. The other group of employees comes from what's called the Ivy Publics, and that is schools like Rutgers, like Ohio State, like Penn State. That is schools that have a very good academic reputation, but they are not private schools. We'll call it publics. And then let's say we have just another category called other schools. And we wanted to know if there was a difference in employee potential based on the type of school that they came from. So we would want to have one blanket statement that there is a difference. Now, of course, that blanket statement is something that we would call an alternative hypothesis, and that would be there is a difference between these 3 different categories. And the null hypothesis would be it is not true that there's a difference, or there is no difference. And what we're assuming here is that this school maybe has higher potential than other schools. This has the highest potential. This has middle potential, and this has lower potential. Now, within these groups, of course, within the Ivies, we're going to have some people who have more potential, some people who have less potential. Within the public Ivies, it's going to be the same thing. And within the other schools, it's going to be the same thing. So, look what we're doing here. We're saying that if they are not different, they would have this average, whatever this grand average is. So we call that the grand mean. But as people tend to be, they are different. And what we're saying is this. Part of the reason they're different, in fact, a huge part of the reason they're different, is because they neatly fall into these three categories. And as a matter of fact, when we put them in these three categories, it explains or it covers a lot of their differences. It explains a lot of their differences. And then the remaining difference is how they're different individually. So this is where this takes us logically. It takes us with the idea that there is this total difference between all of these people in all of these categories, and we can apportion that total difference to group-related difference and individual differences. So suppose we could compare the group-related difference to the other individual difference to see how big the group-related difference is, or how much of a difference that makes. What we would be doing there is we would be analyzing these variances. So we would be analyzing variances. Or we would be performing something called an analysis of variance. So analysis of variance is an ANOVA. It's an analysis of variance to determine if three or more groups are different or not. So now let's look at the mathematics of that situation. Let's take three different groups. We're going to take a group 1, and members of group 1 have incomes of $49,000, $52,000, $52,000, $53,000, and $49,000. And members of group 2 have incomes of $56,000, $57,000, $57,000, $60,000, and $60,000. And we might say that this is the majority group, and this is a group of all minority employees, and this is a third group of international employees. And these incomes are 54, 52, 56, 50, and 53. So, remember, when we're talking about measuring these differences, what we're saying is they are different from a general grand mean. And if we calculate the general grand mean here, you would get a 54 if you averaged all of these 15 scores. Now let's take the group-related means. So if we calculate the means for this first category of group member, the average is a 51. If we take the average of this second group, the minority group, the average is a 58. And if we take the average of this third group, the international group, the average is a 53. Now, on the surface, this looks kind of different. Well, there's a bigger difference between the 51 and the 54. That's 3 units of difference. So they're on the south side of this 54, and then the 58 is 4 units more, and then the 53 is kind of in the middle towards the bottom. So let's see if we could figure out how to do this. If we wanted to, we could take the total difference from the mean of every member here, all the 15 members, and then we could sum those squares, and we would have the total sum of squares within everyone, no matter what group they're in. As a matter of fact, let's do that. So we see this 49 is 5 units away from the 54. We'll square that 5 units. We'll get 25. The next person is 2 units away from the grand mean. Square it, get 4. Next person is 2 units, square it, get 4. Next person is 1 unit away, square it, get 1. Next person is 5 units away, square it, get 25. The next person, first person in group 2, is 2 units away from the grand mean. Square it, you get 4. Next person is 3 units away from the grand mean. Square it, you get 9. Likewise with the next person. The next person is 6 units away from the grand mean. Square the 6, you get 36. The next person is the same. Square it, you get 36. And then the first person in group 3 is a 54. They're right on the grand mean. Square it, you get 0. The next person's 2 units away from the grand mean. Square it, you get 4. The next person is 2 units away from the grand mean. Square it, you get 4. The next person is 4 units away from the grand mean. Square it, you get 16. The next person is 1 unit away from the grand mean. Square it, you get 1. So how many total sum of squares units does this total? So here in this column we have 59, and then 72, 81, 94 over here, and then in the third group we have 25. So if we add the 25, the 94, and the 59, we have 178 total squared units. And that's considering everyone as being part of the one group. They are all 170 in total. There are 178 squared units away from that grand mean. Now remember, up above we said that 178 can be apportioned. One is how much of that has to do with their group membership, and how much of it has to do with individual. And that will give you your total. So by the way, this is called among groups. This is called within, that is within the groups you have individuals. And let's see if we could figure out what the within is. Now what does the within do? The within takes every individual in a group and compares them to the within group average. So in group 1, the within group average is a 51. So now let's take the first person in group 1, compare them to their group average, which is a 51. That's a difference of 2 units. Square it, you get 4. The next person is 1 unit away from the group mean. Square it, you get 1. The next person's 1 unit away. Square it, you get 1. The next person's 2 units away. Square it, you get 4. The next person is 2 units away. Square it, you get 4. Okay. Let's go to group 2 now. The first person in group 2 is 2 units away from that group mean. Square the 2, you get 4. The next person is 1 unit away. Square it, you get 1. The next person is 1 unit away. Square it, you get 1. The next person is 2 units away. Square it, you get 4. The next person is 2 units away. Square it, you get 4. Now let's go to group 3 and see how many individual units those members are from the group mean. The first person is 1 unit away, square it, you get 1. The next person is 1 unit away, square it, you get 1. The next person's 3 units away, square it, you get 9. The next person is 3 units away, square it, you get 9. The next person is right on the mark, square it, you get 0. So let's total these up now. So if we add the 4 and the 1 is 5, and the 1 is 6, and the 4 is 10, and the 4 is 14, so this gets 14 right here. This group, that is the within in this group. What about the within with group 2? You have 4 and 1 is 6, 6 and 4 is 10, 10 and 4 is 14. So likewise, the within sum of squares within group 2 is 14. What about group 3? So we see the 1 and 1 is 2, and 9 is 11, and 9 is 20. So the total within sum of squares in group 3 is 20. So our total within sum of squares is 14 plus 14 plus 20, or 48. So that means this is 48. Now, if we are correct and in believing that our total sum of squares can be apportioned to within and among, that would mean the among must be 130 units. So that raises a question. Is it? Well, let's see. Now, what we do to figure out the group-related difference, is we compare the group average to the grand mean. So, the group average is a 51. The grand mean is a 54. What is the difference? 3. Square it. 3 squared is 9. But that gives us the average squared distances. We don't want the average. We want the total. And we have 5 people in the group. And if the average squared distance is 9, then the total is 45. Let's do the same thing for group 2. So we see the group 2 people are an average of 4 units away from the grand mean. So you square that 4 units and you get 16. But that's the average. We want total. So we have 5 people in the group who are an average of 16 squared units away from their group mean. So 5 times 16 is 80. Now let's go to group 3. So group 3 has an average of 53 compared to the grand mean of 54. So that means they are, on average, they are 1 unit away from the group mean. Square the 1, that gives you 1, but that gives you the average square distance from the mean. You want total, so you have to multiply the 5 people in group 3 against that 1, and you get 5. So now, let's add this 45 and 80 is 125. Add the 125 and 5, and guess what? We have that 130. So it is true. The total variance is made up of the group-related variance, 130, and the within variance, which is 48. And this is not minus. This is, of course, plus. The distance is plus. Okay, now what do we do? Now let me erase this. We have our numbers. And so now we can go to figure out what we have here. What we have up top here is the sum of squares, right? Now we have to get both of these numbers on equal footing. And the way we do that is we divide by the degrees of freedom. So at the group level, how many groups do we have? 3. So we would subtract 1 from the 3, which would equal 2. We have 2 degrees of freedom here. And let's go to the total level. So we have total here. Let's see, how many people did we sample here? We have 15 minus 1 degree of freedom at that level. So that would be 15 minus 1 is 14. So that would be your total degrees of freedom is 14. So that's total. So 2 plus what equals 14? 2 plus 12 equals 14. Or is it 12? Let's go to the top. So we have in group 1, we have 5 people in group 1, minus 1 degree of freedom there is 4. And then in group 2, we have 5 people in group 2, minus 1 degree of freedom is 4. And then in group 3, we have 5 minus 1 degree of freedom equals 4. So we have 4 plus 4 plus 4 equals 12. So you see it did work out. Alright, so we have the sum of squares is 130 among groups or between groups, and we divide by 2 degrees of freedom to get to 65. And then we have 48 squared units of difference that are within, and then we divide that by the 12 degrees of freedom, and that gives you and that gives you 4. So now we have 2 numbers of mean squares, that is sum of squares divided by the appropriate degrees of freedom, so they're comparable directly to each other. And what we know is we have 65 units of group variance for every 4 units of individual variance. And we divide that, so we get 16.25. And now we'll think back to our t-test and know that our approximate number is a 2, and this is huge compared to a 2, so we conclude that there are differences among these 3 groups. Now, importantly, what we cannot do at this point is conclude that there is any difference between one particular group and another group. And the reason for that is this. We didn't test that. All we did was a test to see if there are differences that are significant among the groups compared to standard differences within groups. Now, if we wanted to test individual differences between individual groups, then what we would need to do is a test after a test, also called a post-test. And I'll show you just in a little bit that SPSS allows you to do a post-test as part of the ANOVA in order to determine where you can claim that there are observed differences between what groups. Now let's take a look at how to do this in SPSS. Okay, this is what that looks like when you use SPSS. So let's imagine that we have a file here, as we do, and look at that DOMINT heading. This is domestic or international, and if you can see here, we have our employees in 3 categories. They are either domestic minority, or they're domestic majority, or they are international. So that's how we have this coded, and what we want to know is, are these scores in this exam 1, so this is the first exam in a management training program, we want to know if they actually get off on a different foot depending on whether they are domestic or international, and whether they are domestic majority, domestic minority. So we have three groups. And what we will do here, once we have our data in, we will click on Analyze, and we want to compare means. And we want to do a one-way ANOVA, and we want to, our dependent variable is what? Well, our dependent variable, that is the thing that we think is affected by these categories, is exam 1. And then our factor is whether or not they are domestic or international. So then, oh, look at this. Post hoc here. Okay. Gee whiz. And we actually didn't go into this. So what I'm going to tell you here is that if I ask you to do post hoc, I'll tell you what to click on. And in this case, I'm going to ask you to click on Tukey, T-U-K-E-Y. So I ask you to click on Tukey under equal variances assumed, and we'll click on continue here. Let's see under options if there's anything else here. We can ask for descriptive statistics, you see, if you want to. And let's click this exam one back over here. So now we would just click OK. Alright, now take a look at this top here. So you see under one-way ANOVA, you see that the F value is 4.2, and you can see that between groups and within groups, they total, the two of them total the total, and degrees of freedom, there are three groups, so the degrees of freedom here is 2. There were 18 people who were in the survey, so the total degrees of freedom is 17. And here's the mean square, which is the sum of squares divided by the degrees of freedom. And then we have the F value, and the F value is the mean square between groups divided by the mean square within groups. And you can see the mean value, the F value is 4.27, and 4.27 is significant at a level of 0.034. And that is better than our standard of 0.05. So there are significant differences in exam 1 score based on these three categories. Now, go down to the next table where it says post hoc tests. So what post hoc test does here is it compares the domestic majority. See this first line here, domestic majority? It compares domestic majority with domestic minority, and that is significant at a 0.058. That does not meet our standard. So, look at domestic majority compared to international is significant at 0.102. That does not meet our standard. And then look at these other significance numbers. 0.058, 0.977, 0.102, 0.977. So in this case, look at this. We have a curious outcome here. And that is, according to the ANOVA, we have the right to say that there are differences among the three groups. But when we asked SPSS to compare each group with each other group, we don't see any of them as being significant. And I just have to tell you that that's part of the problem with doing post hoc tests. some of these post hoc tests are a little more liberal, and some of them are a little more conservative. And Tukey is actually somewhere right in the middle, but you can see in this case it is fairly conservative. In other words, it makes it more difficult for you to conclude that you are true, that any of these differences are in fact real. So the key to this, of course, is this big ANOVA result, and you see it looks exactly like the kind of table that we did before. Okay, so here I've replicated the data that we put in by hand just a short while ago, and you can see that a variable 1 is the different groups. So there's group 1, group 2, group 3 that we had them, that is the income. And here are the 5 incomes for the group 1 folks, the 5 income for the group 2 folks, the 5 incomes for the group 3 folks. And we can do an analysis. So we're going to compare the means to a one-way ANOVA. And our grouping variable is going to be variable 1. And our variable 2 is the income here. And so let's do OK here. And you should, and these numbers should look familiar. So if you go down here to this ANOVA, you see the between groups is 130, the within groups is 48. Remember the 178 total. See the degrees of freedom between groups is 2. Remember 3 groups minus 1 degree of freedom equals 2 degrees of freedom. And within groups is 12. And remember the 65 over 4, which is a 16.25. And remember I said that that is huge. And you can see it's huge because it's at degree of significance of 0.000, where you would say that there definitely is a difference between those 3 groups. So that is ANOVA. I don't know what else to tell you. You definitely should know how all of these numbers in an F table relate to each other, what they mean. You should definitely be able to define an F statistic here as a comparison of the difference that's accounted for by the magnitude of group differences compared to individual differences of 4 here. Good luck on your remaining studies.